Hello, everybody. Welcome to our webinar on fatigue essentials. My name is Kyle Hamilton. I'm a stress engineer here at Predictive Engineering.
Good morning, everyone. My name is Chris Johnson. I'm an analysis engineer with 16 years of experience in the aerospace industry, and I was one of the developers of Fatigue Essentials.
Hello, I'm Brian Reiling, and again, I'm part of the Fatigue Essentials team here. Just a little background maybe on how Fatigue Essentials came to be. Most of my background is aerospace. I've got 25 years of experience or so. A lot of complicated components and large spectra. So I've done quite a bit of fatigue analysis. As I moved on and started doing consulting, again, I occasionally needed to do fatigue analysis, but I didn't have access to some of the commercial codes out there. And as I looked at those, they were really pretty expensive for what I needed, and they also weren't really user-friendly for occasional use. So like many people, I just created spreadsheets and made that work, but it wasn't fully acceptable in the big picture. So George and I talked about this, and eventually we decided to create Fatigue Essentials. So back to you, Kyle.
All right, and on the line we've also got our Applied CAX account manager, Eric Barber.
Good morning. Just a quick intro. Applied CAX is basically the software / training arm of predictive engineering when it comes to the software that they use every day, be it FEMAP, NX Nastran, LS-DYNA, Star CCM nowadays, and now Fatigue Essentials. And most of you on the phone are already currently have FEMAP clients, so you already know that our online technical resources, we think, are without equal, and then the fact that we take really great pride in providing outstanding technical support to our clients from our team of engineers that have tens of thousands of hours in FEMAP, NX Nastran, LS-DYNA, and the fact that the FEMAP development team leans on us, on our FEA team, for all beta testing for the new software releases on the FEMAP front. So I always ask folks that are currently clients is why would you not want to be supported by what we think are the true experts in their chosen field. And moving to the continuing education lines, Adrian Jensen, our senior FEA engineer here, has his first ever online API class for FEMAP. Begins on Tuesday, February 21st. 6 sessions, 90-minute recorded sessions, homework. We're really excited about the class, and it's gaining traction here as the date approaches. And then changing gears to just a full devoted FEMAP class, we've got Adrian's class that he conducts twice a year here in ever sunny Portland, Oregon, from April 24th to the 28th. And then finally, George, with his famed LS-DYNA class, focusing on explicit, nonlinear, and large deformation analysis for structural mechanics, is here in Portland as well from May 15th to the 19th. In terms of if there's any interest along those lines, you'll have my contact information. You can see myself with my lovable Labrador Lucy, the photograph there. Feel free to give me a call, shoot me an email. I don't bite. And if you want to hear a fish story or exchange one with me, I'm all ears. So I'll turn it over to Chris and take it from there.
Okay, so good morning once again. To kickstart the proceedings today, I'm going to introduce you to Fatigue Essentials and just provide a high-level overview of Fatigue Essentials and its general program flow and capabilities. As Brian mentioned earlier, the primary aim behind creating Fatigue Essentials was to provide an easy-to-use, intuitive application for performing high-cycle fatigue analysis. It's an affordable alternative for the cryptic, kind of hard-to-maintain spreadsheets and other older in-house tools that are so often used for fatigue analysis when other options have not been historically available. So what I would like to do first, before my colleague Kyle takes over to show more in-depth working use of Fatigue Essentials, is just to provide a general overview of the application, a general philosophy, and how the analysis database is organized and maintained, i.e. creating, modifying, or deleting database entities. So when you first open up Fatigue Essentials, what you'll see is a screen very similar to what is shown here. I've actually opened up one of the example help files that comes shipped with fatigue analysis, and this is just a very simple classical fatigue analysis. You've got your standard Windows menu bar at the top, a message window at the bottom here that just provides some information on what's going on in the database and just provides confirmation that anything that you do has been successfully performed. On the left-hand side of the application is the navigator tree, which displays the contents of the analysis database, and it's been organized in a fairly typical nowadays hierarchical fashion for easy navigation. So you can scan through and you can see the various entities that you can create. So we have load cases, spectra, materials, and analyses. We wanted to keep the user interface of Fatigue Essentials as uncluttered as possible. So when you navigate over any particular item in this tree, buttons pop up that show you what options are available. For instance, I could edit or delete an analysis. If I move over the materials, I can create materials, import material data from a material database file, or you can save it. And this general flow is present throughout each of these items in the database. The main working area of Fatigue Essentials here, where you can see the Fatigue Essentials logo, this is the editor window, and this is where the bulk of the work is performed. For instance, I can go in here to the spectrum, click on edit, and this shows the spectra here that I've previously created. If I include block repeats here, it shows a graphical representation of the spectra that you've created, and you can go in, you can modify which load cases you want applied, you can delete load cases, you can add load cases and insert load cases, and this is a general flow and philosophy that we've tried to maintain throughout each of the editor windows in Fatigue Essentials. We laid it out with a very linear flow to approaching the analysis. You start off by creating project information. Just discard that. So you can go in and you can have engineers who created and checked. You can add fields, as many fields as you like for checkers, part numbers, etc. And then you can move through and add load cases, define your load spectra, add materials or import materials, and then you actually create the analysis and run your analysis from there. However, once you have your basic database laid out, you can jump backwards and forwards if you want to make tweaks to your spectra or your load cases or your materials. The user is very free to do that. And then once your analysis is complete, Fatigue Essentials has several tools to aid in writing reports. So I think this covers the basic flow and layout of Fatigue Essentials. I'm now going to pass you over to my associate Kyle, who will walk you through a couple of worked examples and show you more of the capabilities of Fatigue Essentials.
All right, thanks, Chris. One thing before we jump into these examples is, as you're watching our webinar here, if you have any questions, feel free to just ask them in the questions box of your program. We have some people on the line here to answer those questions, and we'll try to address them as they come. If there's any that we can't get to during the webinar, we'll be posting some documentation, and we'll address those questions after the webinar. So let's go ahead and jump into a simple model. We're going to start from scratch, and the first one we're going to do is using the features of the classic verversion of Fatigue Essentials. And then after that, we'll run through a FEMAP model where we'll run a load spectrum and push the damage back out to the FEMAP model and visualize that. So let's start by creating a new model. And as Chris mentioned, we're just going to start right at the top. The project information by default gives you a lot of options. You can put your name, dates. If you don't need any or certain fields, you can delete them. You can edit the fields on the left here. If you want to say company, this will be Acme. Once you're done putting those in, we can keep erasing things. And after you've edited your fields here, you always need to click the Apply Changes button, and that'll save those changes. First, we'll start at the top with load cases. And you can manually enter your load cases here. I've kind of cheated for this webinar, and I put everything into an Excel spreadsheet, so I don't have to type it out in front of everyone. So I'm just going to copy the load case ID. So we've got the ID, a description of the load, and then the stress values. Copy that and just paste it right into our load cases here. Once I have that in, I'm going to change the stress detail name, call this part 1. With those changes input, I'm going to hit apply changes, and that's saved. Next up, we create our spectrum. Create a new spectrum, and we've got a, let's see, where's my notes on this? So we're going to go with load case 1, load case 2, load case 3. Bear with me while we create this here. And then back to 1. We'll grab load case 5, 1, and then 3. And we've got this option up top here for the number of repeats. But that applies to this load spectrum. We can also separate this into blocks where, let's say I want this into 3 sections. I want this first group to just repeat once, and then I want the second set to repeat, say, 8 times, and then this last one will repeat 3 times. And at first, it doesn't look like it's doing anything, but we can check this box for block repeats, and it shows that full spectrum. Now we have the spectrum, we can give it the total number of repeats, and we'll say 100,000. And let's give this a name, load spectrum 1. Click apply to save, and you can see it's down here in the underneath spectra. And we can add more if we want. For now, let's just keep it simple and go with 1. Now, in our materials library, I'm going to start by loading a material library, and then we'll show how to add one. So let's go ahead and load from file. Got one saved on my desktop here, and we've got this library file. As soon as I load it, you can see we've got some steels, some aluminum. Let's go ahead and add a new material. And this one's going to be 7075. I don't even need aluminum there. You can see every material has a reference. If you have a reference that's other than MMPDS, you can see it'll organize it at the top level of the material library. Underneath that, you've got your types. I just have aluminum and steel for now. You can add whatever you want. You can input any name there. It doesn't have to be aluminum or steel. And then, so these top 3 values are mainly for reference. They're used to organize your library here. Everything from your temper down to your KT value is just for your reference. So we've got the top 3 are organization. The next grouping is for reference, and then these last ones are all used for the actual analysis. So I've got some notes here for my values for the 7075. I'm going to go ahead and remove most of those so I can copy and paste my cycles to failure and my stress levels into this table. And you can see that looks pretty nice. It pastes right in. For FTY, throwing in 70. U, throwing 75 KSI. You can add notes if you want. For now, I'm just going to click apply. And it saves it over here on the left side. With the materials added, you can go back in and save your material data. I'm just going to say, one. So that's saved. Next up, we're ready to create our analysis. We'll click this Create Analysis button. And we've got all these options in here. First one's our analysis. We'll just call this simple analysis. Go ahead and give it a scatter factor of 3. We've got our load spectrum 1 automatically selected. That's the only load spectrum we have. In our materials, we've got this drop-down menu with all of the materials that appear on the left-hand side. I'm going to grab this 4130 bar. For analysis units, this describes the analysis units of the load spectrum that you have. So let's say you input your material data in megapascals or gigapascals, and you've got your load cases input in KSI, you can choose KSI here. This needs to match up with your load cases. Down here in our cycle counting method, before we get there, you can see we've got a lot of different options for the common units. So cycle counting method, we've got the most commonly used fatigue counting methods. We've got peak, range pair, rainflow, repeating rainflow. Let's stick with rainflow on this setup. And then retain stress pairs. We've got a bunch of options. You can choose all of them, 50. That'll affect your analysis time. So choose wisely there. If you want your margin of safety, you can select this box here. And let's go ahead and add some stress modification factors here. So let's see, I've got my notes over on the right. First one, we'll say heat treat, 0.97. We'll add shot 0.85. And let's go chrome plating and 1.24. And you can see the modification factor gets combined and shows you the value that we're going to get up here at the top. And so let's go ahead and apply those changes. And now we're ready to solve this analysis. So to solve it, we select Solve Analysis. And you can see for part one, we've got total damage of 0.835. And it gives you this information, a nice, easy to see layout. You've got your, in one snapshot, you've got your materials, your units, your damage, your modification factors. If you wanted to just get the snapshot and drop it into a report as your backup for your fatigue, there's a button down here where you can just capture a screenshot of the editor. You can also write this out to an HTML file. So let's take a look at what that looks like. Save that. And give me just a second. We'll open that back up and open up our report. And it pops out into this analysis report. We've got all the information we put into project information. We've got our load cases, what the spectrum looked like, material information, and our SN curve information, our damage summary, and the stress pairs. So with that, let's go back and take a look at some of these material options. I showed a tabulated way to make this SN curve. We know that not every material is going to have a cycles to failure and a stress level, and we tried to make this a flexible material editor based on that. And so we've got a couple different options. You can do a tabulated one. You can also do a logarithmic curve fit, where you put in your coefficients. And we also have the estimate from strength data. So if you just need a rough analysis and you don't really know much about your material other than what your yield and ultimate strengths are, you can get a rough estimate here and just see, is your part going to just get destroyed or is it going to be pretty good? If we go back to our tabulated, you can see I've got my yield set up at 36 KSI, and then our it defaulted back to our old stress level. So the curve looks a little funny right now, but we can cancel our changes and go back in, and everything looks good again. So one of the other options we have in our material editor is we can tell the material editor what the input R ratio was. So right now we have it matches the MMPDS at -1. If your data comes with a different R ratio, you can input that depending on what that is. By default, we have the Smith-Watson-Topper stress correction. We've got modified Goodman, Walker, or you can even create your own stress correction method if you have a methodology that you really want to put in here. Go ahead and go back here. And if you want to use different R ratios, or you don't need to show your 0 or 0.25 values, you can get rid of them on here, and it'll get rid of those extra curves. But let's go ahead and leave them. Oops. All right. So there's our material editor. We've seen our simple analysis using just the classical version of Fatigue Essentials. Next up, we can take a look at how to do it with a FEMAP connection. So give me just a minute here. We'll create a new Fatigue Essentials project. Now, the running Fatigue Essentials in conjunction with FEMAP is fairly similar to the classical method that we just looked at. You're still going to need a spectrum. You're still going to need materials. The difference is your load cases get pulled in from FEMAP, and the analysis, we have an option to push the damage plot back out to FEMAP. So we've got this nice rod end here. We're going to look at the two load cases. One of them is the compression load case, where we've got our stresses here, and one of them is tension. And you can see both of them light up this little neck here quite a bit. And the tension load case lights up this spherical area on the edges. So with that, let's take a look at how to actually walk through this analysis. Before we get into there, did anybody have any questions, or we haven't gotten any questions on our little tab here, but now it might be nice to separate them out into the simple analysis and the GMap analysis.
Hey, Kyle, this is George. I thought I'd jump in. Greetings. I'm one of the coordinators of Fatigue Essentials. I wanted to mention what you just saw on the first part, the hand entry. That's what Brian's group at Endeavor. That's what they really like about this program. It formalizes the fatigue setup, and it's really quite powerful. It's a heck of a lot better than a spreadsheet because it's hard coded. And one of the driving forces to make it hard coded is that when you have a spreadsheet, things get changed. Spreadsheets get passed around. People touch them, things get broken. Pretty soon you've lost all continuity with the original development on it. By formalizing it and locking it down, you know what you got. And there's also a lot of error checking that went into this. Years of error checking that went into this. So it may look like this. So you might look and say, wow, that's really easy. Well, it's not. There's a lot of stuff that went into on the back side of this to make it robust, to make it work. And there's lots of ways to enter curves for fatigue data. Kyle just shows you tabulated. There's, I don't know, Brian will tell there's more ways than I know. So that's what I wanted to mention real quickly here formally. And then what Kyle will show on the next part is integration with FEMAP, which is our side on the predictive engineering where we're interested. So back to you, Kyle. Okay. Oh, one last hand. Go ahead. I'll jump in. Sorry, Brian, to cut you off. In the audience, please, there's things on the side of the panel to ask questions. And we have the whole team here to answer any questions that the participants might have coming up. It's a little chat box on the side. Okay, Brian, all yours.
Okay. Yeah, I was just going to touch on those same things again real quick. You know, like Kyle showed you, we have a couple methods or 3 methods for entering the curve, and we just tried to keep it really flexible. For sure, most of the aerospace people are really comfortable with the MMPDS curves and that logarithmic curve fit, but sometimes you just have a piece of paper with a curve on it, and it's just easier to pick points and put it in a table and punch it in like Kyle has shown here, so with the tabulated method. Same for the mean stress corrections. We default to the Smith-Watson topper, but we also have the Goodman there, you know, because that's a pretty standard method as well. there's the Walker method, which is kind of more what you see, again, what you see in MMPDS, where you kind of have a modified exponent to the Smith-Watson topper thing. And then there's the none option, which you use sometimes for the ASME boiler stuff, where they don't really want you messing with mean stress corrections. So again, we tried to kind of pick the standard ones. And then Kyle, just a reminder as you go through to make sure you highlight the ways that you can import the loads and spectra from a file as well as typing them in. So, and I'll let you go back with that now.
Good reminder on that one. Yeah, so I showed copying and pasting from Excel into our load and spectra. You can also click this button to load the data from a file, and you can bring it in from a CSV file there. That way you don't have to type it out like I did here. So let's go ahead and jump into our FEMAP example. This is the version that I get really excited about, because when I'm doing analysis on a part or fatigue analysis, you kind of pick some points that you think are going to have high fatigue damage, and you can get a pretty good judgment on it. But I always kind of wonder what the rest of the parts or what the rest of the areas of the part are doing as I pick those points. And so with the Fatigue Essentials Beamout plugin, you can actually plot that damage across the whole part. So here's our part. It's fixed on the threaded end on the left here, and we've actually got a little spherical bearing there that's pulling it in tension, and then we also have a version pushing it back in tension or compression. So let's go ahead and get started. We've got our project info, same thing. This is exactly the same process as the classic method. We'll just put something in here and get rid of the rest of these. Apply those changes. Now, we click up on FEMAP in the toolbar and select Open FEMAP Interface. Now, there's two components to this. One of them is where you select your data, and the other one is exporting the results. Right now, we don't have any analysis completed for this, so we have no analysis down here. So we need to pull the data from FEMAP first. The first method or first step to this is grabbing or choosing the stress types that you want to pull out of FEMAP. I'm going to stick with the maximum principal stresses. And then depending on your element types, we've got our plate elements, our solid elements. We're going to stick with our solid elements on this model. So first we click the button, select output sets and nodes from FEMAP. So it jumps over to FEMAP, and we've got our output set window. It automatically selects the activated output set, but we can select all of them. So we have our compression and our tension output sets. Select OK. And now it's asking to select the nodes that we're going to pull the stresses off of. This joint has about 60,000 nodes, which takes a couple minutes in Fatigue Essentials. So I'm going to cheat, and I have a group here of just my surface nodes, and this will speed things up for the demo. You don't have to choose just the surface nodes, but it'll plot the values we want for this. So let's go ahead and select OK. So now it's importing all of those nodes and their stress values into Fatigue Essentials. And you can check your message window down on the bottom. It says we've got our 14,028 stress details created with 2 load cases, and it confirms that it was successfully grabbed from FEMAP. If we peek down here at FEMAP, you can see I selected 14,028 nodes to import the data from. So it's confirmed that everything imported correctly. If we really want to check what happened, we can click over here on our load cases to modify the stresses, and you can see each node has its own stress detail, and each stress detail has 2 load cases, one for compression and one for tension. From there, I'm going to apply that, and we'll create our spectrum. And let's go ahead and call this compression, tension, cycle. Something simple. So we have our first point is our compression. Next up is tension. And we don't have any blocks or anything in this cycle. We're just going to repeat it. Let's repeat it 4,000 times. We'll apply that. And now our spectra for compression tension cycle is in there. Let's go ahead and load our material data from that previously saved version. So we'll click the Load Materials button, and we'll do this -01 file that I just saved. And it loaded up our steels and our aluminum. And after we have our spectra and our analysis, our spectra and our materials, time to create our analysis. So let's call this rod and GT cycles. Let's give this one scatter factor of 1. We've got our compression tension cycle spectrum. For material, we'll call this one steel again. This time our analysis units are going to be in PSI because the FEMAP model has the units in PSI for stresses. So we want to make sure we match up those load cases to our units used here. In preparing for this presentation this morning, I did a last-minute check, and I had it selected as KSI, and I was very confused at what was going on in our damage. So it's just like everything else in analysis. You want to make sure you keep track of your units. For our cycle counting method, we're going to stick with peak count on this one. All right. So got that all applied, and we don't need to do any modification factors here. Now, since we've got 14,000 stress details on this one, it takes about 30 seconds to run. So just bear with us here, but the results will be worth it. Let's take a look and see if we've got any questions coming in.
Kyle, let me jump in here. This is Brian real quick. I was just going to note there on the screen you have a box that's not ticked that's calculate margin of safety. And what that does is it calculates what your stress-based margin of safety of your particular detail is. So how much you can increase the stress to get to a damage of 1, or how much you have to decrease the stress to get to a damage of 1. And that's got a toggle on it because it does take some time to iterate through that solution. So if you're just checking a few details, that's a really nice feature to have. If you're checking 14,000 of them, it'll run faster with that box not checked.
Okay, great. Thanks for jumping in there. I'm glad I have it non-checked on this one.
Yeah, and this is George Larry. The reason why Brian wanted that in there is clients will ask, well, hey, how many cycles can this thing run before it fails? And yeah, you know, the old school, you can iterate around on it, but it's not as simple as you think. It takes some time. So that's why that factor is in there. You can set it up and automatically, optimize to that point. Hey, Brian, while you're there, I know you're there. There are some questions coming in on the side.
Okay.
You see that? They're tailored towards you. And,
okay. Let me
on
see
the question pane. And I let them know that you would be answering them.
Okay, let me see if I can.
Okay, Kyle, back to you. I'm going on mute.
Okay, yeah, Kyle, I'll take a flip through these questions and let you wrap up here.
All right, I thought we were going to put you on the spot and answer live. We'll circle back to those. So now that we've got our analysis complete, we've got our damage up here, and you can scroll through and see your stress details and what the total damage is on those. And that's great. You can check node to node, but what we really want to take a look at is pushing it back out to FEMAP. So I'm going to go back to our FEMAP plugin. We'll open up our interface. Now we've got this rod end compression tension cycle analysis that's loaded up in our export results menu. And to push this out to FEMAP, all you do is click this button, send results to FEMAP. And it will automatically, so we've got our Fatigue Essentials output data output set. And within this output set, we've got a output vector for accumulated fatigue damage here. And this is a value of 0 to 1, 1 being your damage, I guess, benchmark. And if we scroll around here, you can see this neck where we had our high stresses is just lighting up. And we've also got some fatigue damage on these parts of the edge here where we saw that high tension stress. But the necking down region here is where we're really seeing most of our fatigue damage. This region inside here is where all the constraints are. So in GMap world, that's not a really useful area to pull our stresses off of anyways. So here's our fatigue damage plot. And we did our demo with some with tetrahedral mesh. We can also do this with plate and hex mesh. I'll go ahead and load up a couple examples here. So we've got our wrench, which has some nice hex meshing. On this model, we've got most of the damage is up here in this little corner. And I wanted to highlight the other areas that might see fatigue damage. So I went into FEMAP and changed my contour levels and just dropped it down to 0.2. If we have it at 1, we don't get that much resolution in where the areas might get some fatigue damage. And so you can play with this as if it were any any output set in FEMAP. Let's see. So there's that, and let's take a look at our plate model also. We've got this big wind turbine tower. And turning on the label max min can be really useful because in this model, most of the structure doesn't see fatigue damage. If we look around, this whole base looks pretty solid. Got a couple little spikes there in the middle, but as we move up to the top, it's really this mounting plate that's seeing the most fatigue damage. And so this can be pretty useful. This is why it's useful to have your GMap contour your fatigue stress, because you might pull out a couple different areas of stress levels as you're doing your hand crank your fatigue damage. But this is really all-encompassing. It grabs all of your nodes that you select, and it'll calculate the fatigue damage for all of them. And then, as a bonus plus, you get a nice picture to put into your engineering reports. And who doesn't like pictures? So that's our FEMAP plugin. Brian, did we have some answers to some of the questions that have come in?
Yeah, I kind of hosed something up on my side. There's a first question that came in that I just see the end of the question, and I somehow lost the rest of the question. Do you have it there, Kyle? And can you read that to me, and then I'll go ahead and answer the whole question.
All right, we do get to do some live Q&A. I'll start at the top. Looks like from the questions we received first to the most recent ones. So the first question is, will Fatigue Essentials accept EN curve material data?
Hey, Kyle, I've been answering them on the side. This is George Laird. I've been answering.
That's why they're disappearing on me. Okay.
No, they're there. You just got to open the pane. It's a software thing.
Okay.
No, I'm going to give you the hard one. It's for Miguel. Is the program able to analyze fatigue in structural steel sections loaded in tension and flexural stresses?
I think the answer for that is yes.
Yes.
So,
yeah, I know. It's just complicated load cases. So what Kyle has also said, you just set up multiple load cases for the model spreadsheet. No, sorry. I answered that for you, Brian. That's rude.
Yeah, no, I mean, I think you're right, George. At the end of the day, it's just a stress at a given point, and once you've calculated the stress for your load cases, you just run it through just exactly like the examples Kyle's done here. So.
Okay, here's one for you because the guy's talking about landing gear, so maybe he knows you. So I should mention Brian was chief engineer for Messire Dowdy on the 787 landing gear set, and that's where I met him because I I spent a bunch of time up in Seattle working on that stuff on the proposal side. It's how would the program preserve node IDs in moving assemblies such as landing gear?
That is a good question. I think, Chris, if maybe you can help me out here, but I think as long as the node IDs don't change, it's just a detail with a name. So as long as the nodes stay constant, it's just a stress for a different load case.
Yeah, that's correct. When you pull that data in from FEMAP, that node ID is what Fatigue Essentials maintains so that it can communicate correctly with FEMAP. So when you bring in that node ID, that becomes constant, and there's a stress value associated with that and a damage that becomes associated with it once you run the analysis. When you push that node ID back to FEMAP, that needs to remain constant. Otherwise, there's going to be some confusion when Fatigue Essentials and FEMAP talk to each other. So if that node ID does change, say if you remesh the models, I mean, when you send the data back to FEMAP, it will no longer have any valid meaning.
Yeah, and it looks like he's followed up on that too. So again, if the node IDs change, then that doesn't work anymore because you actually then have a different detail that you're working on, or 2 or 3 different details, when in fact you really want them to be the same point.
Yes.
But it is interesting to note that he knows the game about, remember what you're doing in B models, you were saying, no, you got to keep the nodes. We keep them in node sets and we never change them. And
yeah.
There's some other ones here. I think we can answer those offline because we have the email addresses. On my side, that was a really nice presentation, Kyle. I liked it. Everything worked. But one guy did ask, I haven't checked around. Hey, Kyle, have you done any really large models, like 1 million nodes?
From everything, the max that I've tried is about 60,000 nodes, and it just takes time. I think I mentioned 60,000 nodes takes about 2 minutes.
Oh, okay. 60,000 nodes in 2 minutes.
Does it scale linearly? I mean, it seemed like it's going from...
Well, this would be a question for Chris. You programmed it. What do you think?
Yeah.
1 million nodes?
I mean, I'm sure it's hardware dependent. And obviously, you need to store these calculations somewhere, so it's going to depend on the specification and the computer you're running on. I haven't really done any proper stress testing of really large models. In theory, the program should be able to cope with it if you have the available RAM for this thing to actually store your calculations in. What you have to be careful of is, if you're running a model with 1 million nodes and you have a complex spectrum, you need to run, a rain flow or a peak counting or range pair or whatever on each of those nodes. So I think in theory, is it possible? Yes. I think that the preferable approach would be to kind of look at your model and see where your problem areas are going to be and narrow your area of investigation down to areas where you suspect that damage may be greatest. I think that's the preferable approach.
Then the shotgun, massive data.
Yeah.
And you lock up your computer and you come back after lunch or a couple hours. And look, it's still cranking.
Yeah.
Kyle
and it's also
out,
dependent. Oh.
Yeah. Kyle pointed out too, on fatigue, most structures are driven by bending stresses, so everything's going to be on the surface. So on FEMAP, it's pretty, Kyle, hold on. It's pretty easy. You just go to the pick button. You were there. I didn't say close it. Go back. You were just there. And
getting ahead of myself here.
Let's go ahead and
grab
and go to the pick and go on faces, and you can pick, hold on. Oh, can you hear me? Thank you. By faces, there you go. And click, and then by faces, you can pick everything on the outside real simply. There's another command. Hey, Adrian, I think you can just pick everything on the outside. I think there's another. It's like here, I've been using FEMAP for 15 years. I'm still finding out stuff on it. But anyway, there's lots of, the point is, there's some very simple ways, effective ways, just you pick all the notes on the exterior of the part. And that is where the fatigue damage is most likely 99.99% going to be. I don't know, Brian?
Yeah,
Ever grab anything on the inside?
No, again, because really the high stresses are going to be on the surface, and really the time a crack initiates from inside the part is more if you have a flaw, and that's not what you're really checking here.
So in the audience, is there some learned expert on fatigue that says, oh no, we always look on the inside of the part too for fatigue? Let me know. I'd be curious about this. You know how it goes. It'd be nice to know. No, 100%. It's always on the outside.
Yeah. We've just got another question in here from Larry Pilkington regarding how does the program handle fictitiously high stresses due to a coarse mesh? In short, it doesn't. Fatigue Essentials doesn't discriminate between, theoretical, stresses.
No, that's a good point. I know what he's saying. It's like that you put a cap on it and ignore all stresses, because this is high cycle fatigue. And what I've been told from Brian and Chris is that anything 80% of yield is up to 80% of yield is high cycle. Right, Brian?
Yeah, that's kind of the number that gets thrown out. I think, most of us fudge that number higher, but I think that's kind of a standard number.
Yeah. So, yeah, well, when the guy said, oh, well, gee, could you put a cap on it? A filter that you could have it obey as it reads in.
Yeah, I think that's a valid question. Sometimes you have boundary stresses if you have contact, or you have things like that. Yes, and I think that's the user's area to go back in and assess those stresses and filter them out on the FEMAP side.
Yeah, but I think what he was asking is, does it have a way to filter stress, or ignore stresses that are under 40% of yield, ignore stresses over 80%. I think that's going to be Rev 2, Fatigue Essentials. Huh, Chris?
Yeah.
Yeah, if there's like anything, as one of the developers, I'm more than happy to, entertain additional features that users request. So as people start using the program and they think, hey, this would be a great idea if the program did this, that's obviously something that, as one of the developers, I'd love to incorporate. So we're always open to feature requests, and nothing is out of the realm of the possible.
Yeah, exactly. And I want to mention to the listeners out there that this, although it says Rev 1 on it, is that right? I've lost track. Does it? Hey, Kyle, what does it say on this? Is this Rev 1 or Rev 2 or? Thank you. Rev 1.0.86. I think we're about at 86 revisions, huh, Chris?
No, that's, as I go through and I add features or tweak features, I just update that for traceability. So.
Yeah, there was a Rev 0 too.
Yeah, it hasn't been through 87 revisions. It's just, like I went to version 1.
Feels like it. No, the reason why we're doing this seminar is that this is ready to go out. It's a production version. We have been beaten on this. We finally just said, okay, look, time to seal it up and get it out there, because it's as polished as we've been able to get to it from our usage. We've stomped on everything we have found through it. So, hey Brian, what year are we? Are we at year 3 or year 4 with this program?
I think we're at year 4. We had some hiccups initially and had a little delay, and then we kind of picked up in there. And I think with Chris and his team, we're probably a couple years in now. Yeah.
A couple of years. Yeah, so it's well honed. What I'm saying is it's, you know, software sometimes can be vaporware. This is definitely not. This is production. You can actually generate results and give it to your client, and not have to worry that something's cooked somewhere. Hey Brian, how many years have you been doing fatigue?
Oh, wow. A long time. You make me feel old, George. Probably, 20, 22 years or so. So again, most of my experience is aerospace and a lot of landing gear, actuation, hydraulic components, kind of miscellaneous structure stuff.
Yeah, and that's, yeah, I won't say anything. How many years I've been doing FEA? But one of the concepts is on the program is that when we release it to the public for commercial use, we want to get feedback on it. We want to use for it, and we'll work with you on making sure that it's value added. That it achieves its mission, providing data. So.
Yeah, I think that's a good point. We've really tried to hit the meat and potatoes of fatigue analysis, and there's always going to be other features to add and other things that might be helpful and all that stuff. And we're happy to evaluate those things, but I think we feel like we have a program out here that for a user that understands fatigue analysis, this will more or less get the job done, or will get the job done.
Hey, your comment. The reason we're focused on the high cycle fatigue. We didn't get into low cycle. We were talking about plastic damage and stuff, and it's just one of those things. Most of the market, at least on our side of predictive engineering, it's high cycle fatigue. When you start talking fatigue, yeah, we're versed in fracture mechanics, and things go great, but the design world, it's high cycle. They want it to work.
Yeah, I mean, even in an aerospace, side, a lot of it is stress life. If we had a huge user base that was looking for strain life analysis, that's something we can look at. Most of the basic functionality is there. It would just be, really updating the rain flow algorithms and some of that stuff to accommodate the strain life stuff. But at this point, we just didn't see that as a big market, but maybe we're wrong.
Not for me. Anyway, who knows? I'm just a little fish in a very, very big sea. What else? It's 9:24. We try to keep these at an hour, all our technical seminars. I don't want to bore our attendees. Anything else?
I think just to note, for anybody who has more detailed questions or thinks of a question later, send them in and we'll get some answers back to everybody.
Kyle, time to close? What do you got? Oh, good.
Yeah, I just wanted to mention, so we've got this this PDF that goes along with the seminar. It covers everything that we went through today in a nice PDF version with snapshots, and a couple sections have a few more details. You don't get all the great insight from Brian and George along the way, but if you have just general questions about the program, you can email me. For sales questions, you can contact Eric Barber. Programming questions, we got Chris Johnson's contact information, and those hard-hitting fatigue questions should be directed towards Brian. And this will all be available on the Applied CAX website shortly.
Right, and along with pricing information. You too can be a fatigue expert. I think. Someday. I just call Brian.
Be a fatigue expert, right?
It's sad. I just call Brian. Hey Brian, I got this fatigue problem. So
all you need to know is red is bad, right?
Yeah, that's the trouble. You become weak. As a consultant, I don't try to know everything. It's a hopeless task. Hey Kyle, speaking as your boss, you did a great job. Good job.
Thank you.
Very nice.
Appreciate that.
And 9:26. Hey, 4 minutes to serve. Got questions answered. Brian, Chris, last comments?
None from me.
Yeah, no, I think that's it. Just thank everybody for attending, and we'll talk to you all soon.
Talk to you all soon. Kyle, close her down.
Everyone, shutting her down.
Thank you, everyone.
Okay. Bye, guys.